Calculate the hang time of an athlete who jumps a vertical displacement of 0.75 meters. Well, our athlete starts here, our comic book, jumps up to be here where they hang for a split second, and then falls back down to the earth. For a split second, they hang there, so I know that velocity right here is 0 meters per second. And I also know that this displacement is 0.75 meters. So I want this velocity to be an initial velocity, so I'm going to kind of ignore the first panel, and that means that that's an initial velocity. Velocity initial equals 0 meters per second. Displacement in the y also is 0.75. Now this is critical because what direction do they go in? They go downwards, so that needs to be a negative. And I know that acceleration due to gravity is negative 9.8 meters per second squared. We're looking for time. And right now we're looking for the time to fall. We'll get hang time eventually, but let's find time to fall. So I know that displacement equals velocity initial times time plus 1/2 acceleration times time squared. Okay, so I know that displacement is negative 0.75, which equals, and velocity initial is 0. I don't know what time is, plus 1/2 negative 9.8 times time squared. Well, this blows up because it's multiplying by 0, so I get negative 0.975 equals negative 4.9 t squared. Can divide this side by negative 4.9 so that these two cancel. Whatever I do to the right, I need to do the left. So t squared equals 0.75, negative 0.75 divided by negative 9.8 gives me 0.0765306. But to get rid of this squaring, I'm going to take the square root of this side and the square root of this side, and t to fall equals 0.27664116 seconds. In order to get hang time though, time hang, I multiply that by 2. And you get 0.553283 seconds. I have two significant figures, 2 sig figs, 0.55 seconds.